Okay, so the recording has just started. So let's just start. Let's just start with this. So AP Systems DS3 installation training. Thanks to all of you who have joined. My name is Ravi. So anyone who has not met me personally, I think it's only John from the lot who has not met me personally, and probably Aaron from Racetech. So Ravi Tucker. So I'm the sales director for Australia and New Zealand. Then we have Nigel, who will introduce himself shortly. So he'll take care of the installation and the commissioning side of things as well. So he'll probably take you through how to troubleshoot, how to remotely troubleshoot the ECU and the inverter system in case of the problem or any RMAs, which makes things easy for you as a distributors and also for the installers as well. Then we have recently hired a marketing executive as well for Australia and New Zealand. Her name is Apurva. So if we have got like any brand campaigns that you want to run in association with AP Systems, then she's the person to go for. Next. Okay, so a bit of a housekeeping stuff. Feel free to ask any questions in the middle of presentation if you have. We'll definitely have question and answers session at the end of the presentation, and copy of PowerPoint will definitely be provided to all the participants once we are done with the presentation. And as I already mentioned earlier, that the webinar is being recorded. So we'll upload the recording of this webinar on our website on apsystem.com.au. So in case if you want to pass it on to any of your installers as well, then yeah, feel free to do it. So for the agenda, I'll take care of the product overview and accessories and system design and installation as well. Then Nigel will take you through to commissioning on EMA Manager part, customer account setup on the EMA portal, and troubleshooting with the EMA portal. So EMA portal, it's actually the EMA Manager app on which you can do remote troubleshooting. You can monitor the systems and whatnot. So let's just start with the product overview and accessories. DS3. So DS3, most of you are distributors, so all of them are aware of the DS3. So let's just start with the nomenclature on what the name of the DS3 actually suggests or means. So D as in dual input, S is split phase, which is like single phase, and 3 is third generation. So it's like the successor of YC500 and YC600, which is why we label it as a third generation inverter. So, and which is why we have named it DS3. Next. And there are like 4 DS3s. So DS3S, DS3L, DS3, and DS3H. So DS3S has an output of 625 watts for Australia. DS3L is 750 for Australia. DS3 is 880, and DS3H is 960. As you can see, like the limits are slightly different depending on the countries, but we'll just focus on Australia at this point of time. Now, let's just see like what's the maximum panel wattage that you can couple with those DS3 inverters, because this is like the most important questions that I usually get from most of the installers. So for DS3S, whose output is 625 watt, you can couple 2 panels, each of 415 watt. So that will make it like a total power of around 830 watt to claim the STC. So all those limits are to claim the STCs to make it compatible with the REC. So for DS3L, similarly, the output is 750 watt, and you can couple the modules of up to 500 watt. So you can put like 2 modules of 500 watt each to make it 1000 watt, and on one DS3L microinverter. For DS3, it's 880 watts. So you can couple 2 modules, each of 585 watt together with one DS3 inverter. And for DS3S, the DS3H, sorry, it's 960 watt. So for 960 watt, you can go till around 640 watt on them. Next. And these are like the microinverter type. So DS3 is currently here in Australia. We have that readily in stock available, DS3S, DS3L, and DS3. DS3H, we usually don't keep it in stock because those are like high wattage inverters, and we usually get them on demand. So if you have like a commercial project, or if you have a demand of around say 400, 500 odd inverters, you can let me know in advance and I can arrange that for you. If not, then we have got like DS3S, DS3H, DS3S, DS3, DS3L readily available in stock. And now, as you can see, the DS3 series can be grid tied with the single phase or three phase. And our next series, which is like natively three phase, it's QT2 for DS3S. It has two channels, so dual channel, dual input. And for DS3D, the only exception is again dual channel, but high input voltage. So you can put like two modules in series on each of the inputs. So you can actually put like 4 panels on one inverter with DS3D. With QT2, pretty similar, but it has got quad channel. So it has 4 inputs. So you can put like 4 panels on one inverter, same as DS3D, but here it has 4 separate inputs. For DS3D, it only has 2 inputs. So that's like the only difference. But for QT2, the main advantage is it's 3-phase. So your installers will not have to worry about balancing the phase. So he can just, sorry, I'm just giving access to someone. Yeah, he can just like install QT2 on demand, like without worrying about how to balance the phase. Because when it comes to the installers, if they have to install like say 10 inverters on a 3-phase property, then balancing the phases becomes a bit tricky, because then they'll have to go 3 on one phase, 3 on the other phase, and 4 on one phase. So the phase where they have to connect 4 inverters, it might become a bit more overloaded at times on a day like today when it's a bit more sunny. So that might create a bit of problem. But with QT2, it solves this problem. So say if you want to go with say 4 or 5 or even 10 inverters, then you can just connect it with the 3-phase bus cables and you're good to go with that. So yeah, that's like the basic difference between 3-phase and single-phase connection. Next. Okay, so that's about the inverters. Now let's talk a bit about the gateway, which is ECU-R and ECU-C. So state-of-the-art energy communication unit, so that's the ECU, and information gateway for AP systems microinverters, collects and transfers module performance data in real time. So with ECUR or ECUC, either of them, you'll be able to monitor panel by panel production data and see how much each of your panel is producing, and control over each individual module for optimized performance. Wi-Fi or Ethernet backhaul, cellular capable. So both of them are GSM module compatible if you want to connect it with your cellular phone, but then both of them have got the Wi-Fi port. So you can just use the Wi-Fi router, which most of the installers do, and customers prefer that as well. But you have the Ethernet connection as well for hardwire connection. Then they use Zigbee communication to communicate with the microinverters or internally. Simultaneous inverter polling. And for export limiting and consumption meter, there's only one option that you can go from either of the two, which is like the ECUC. So ECUC sits in your switchboard and it needs to be hardwired, while ECUR can just sit outside like your normal Wi-Fi router modem, and it has PowerPoint connection only. So that's like the basic difference between the ECUC and ECUR. So most of the installers or customers, they are happy to go with the ECUR instead of the ECUC, because ECUC is slightly more expensive in price as well. But then if the customer has got like some export limitations, or if they want to use a consumption monitor to monitor the consumption, then they'll have to go with the ECUC instead of the ECUR. So that's like the only difference between the two. Next. Zigbee communication. So Zigbee is the protocol that we use to make our inverters communicate with the ECU. So you get like the maximum monitoring range as possible. So as you can see, you can connect like 75 inverters per ECUR, and the Zigbee range is 75 meters or 250 feet max. So if it's an open field, it will be a good signal. But if it's like, say, a metal roof or something like that, then the signal strength might be hampered by that. And even the internal communications between the inverters is through Zigbee. So, and Zigbee is a bit more faster and reliable. Zigbee, I think we are the only ML. We are not the only MLP solution, but then when it comes to the market leaders for MLP, they use PLC and not Zigbee. So when it comes to Zigbee, it's a bit more reliable and it's a bit more faster than the normal PLC communication protocol, which is used by all the other competitors. Okay, let's talk a bit more about the trunk cable. So the trunk cable that we use is same for DS3, same as we used to use for the Y600 and QS1. So there are like two models, or you can say two types of bus cables that we have, 2 meters and 4 meters. As you can see, the rated current for all those inverters, it's different. And the maximum units per 2.5 mm square branch is recommended, like as per the data sheet that Nigel has actually highlighted. But as you can see in the tip, he has mentioned that most of the installers use 25 amps breakers with the 120% rule, which is a bit more prominent here in Australia. You might want to consider using up to only 7 DS3S inverters instead of 8 in one branch, in one string. So that calculation that he has given, like 2.7 multiplied by 8 multiplied by 120%, it's 25.92 amps. So the total amps in this case, it just throws it like a bit more than 25 amps, and which is why I have seen that most of the installers, they keep on complaining that if they are using DS3S and they are connecting 8 inverters in one branch, then the DS3S keeps on shutting down. So if you will use 7 inverters in one branch instead of 8, then that problem might be solved. You will not have that problem with DS3L and DS3 because you'll be using only 6 inverters in one branch. And with that, the amps is way more lesser than 25 amps. So you'll be fine using a 25 amp breaker in that case. If you want to use 8 AS3S in one branch, then probably you can just go with a 32 amp breaker instead of a 25 amp breaker, and you will be fine. But most of the installers here, they'll only use 25 amp breaker, and which is why Nigel has actually put down a tip that, okay, if you use 7, then that will be a bit more feasible, and it will be like prevailing to less prone to customer giving you a call saying that, okay, my inverter is not working in this case. So yeah, that will be avoided.
Hi everyone, it's Nigel here. Yeah, so Ravi has pointed this out. That's quite important because I know in Victoria and Tasmania, when you commission a system, you do get like a third party to verify the system before it can be switched on. And I know that in Victoria and Tasmania, they do have the 120% rule as a buffer. So it might not be relevant for other states. So you might be able to use 8. But just be mindful if you're in Tasmania and try to use 8 DS3S on one trunk, and I can't remember the name of the body in Tasmania. They come and say this is 25.9 amps. You have to change the breaker or you have to take one inverter off. So that's why I mentioned that, so you don't have to waste time to get things changed. Thanks for that, Ravi.
Right. Thanks, Nigel. Can we go to the next slide? Thank you. So let's just have a look at the accessories that we'll be using. Most of you are definitely aware of this as you guys are already selling it. So end cap for AC bus connector cap, disconnect tool, MC4 caps, male and female, and AC connector split phase, male and female, and DC extension cable. So we'll have next slides where we'll be able to show like where you will be able to use those accessories. So let's go to the next part, which is system design and installation. So this is just the normal system overview on how your system will be wired. So this is a kind of single line diagram, which can be used as a reference for single phase and three-phase connections both. So as you can see, all those modules, they are like paired in one inverter, because all this is like a DS3 single line diagram. Then that connection is given to the AC junction box. So instead of AC junction box, you can use the male-female, AC male-female connector as well, which I'll show to you in the next slide. And AC distribution box goes to the power, and then comes the ECU in picture. So the zigbee protocol is used to communicate internally between the ECU and the inverter, so your customers can monitor the system production and consumption through the EMA Manager app. And obviously it's connected to the internet. So this is like a bit more detailed diagram, I'll say, with the use of accessories, which gives us a bit of an idea on where each of these accessories will be used. So as I said, junction box or AC male-female connectors, AC connectors, which you can use. And with the DS3, we can use one or two modules. Disconnect tool, I think that's a bit more important as well, because most of the times installers keep on complaining that the inverter, when we actually connect the inverter to the AC bus cable, they are not able to pull it back off in case of RMA. So you will just have to get a disconnect tool, which is an inexpensive accessory, I'll say. So if they'll use this disconnect tool, then it will become easy for them to disconnect the inverter from the AC bus cable. Plus, the other most important thing is the caps, like the MC4 caps for potential unused DC connectors, and also the AND cap for AC bus, plus the cap for potential unused AC connector. So all these caps needs to go on the unused places where the installers are not using that connection, because what happens is like they'll not put those caps, and then the water will go into this holes, and it will just create a bit of a havoc in when it comes to the overall system performance. And there were cases where it has produced a bit of a short circuit as well, and the system has stopped performing due to that. So please urge all your installers to use all those caps, even the AND caps as well, for safe and efficient installation, I'll say. Okay, so this is the layout. So let's talk about the portrait layout first. So this is how the inverters will be wired. As you can see, there is like a 2 meters between each of the drop. So you can use the normal AC bus cable, which is like 2 meters long. And the tip here is like the microinverter should be installed under the panel and not in between the panels. So that will just increase the life of the inverter. Plus then it will also avoid any direct sunlight on the inverter. So that will definitely be a bit more helpful in the long run as well. And there's another layout. So this is landscape, but this is like landscaping in 2 rows. So it's fairly similar to the portrait, but it's just that it's all in horizontal instead of vertical. So again, as you can see, there is like 2 meters between each of the drop, and you can use the AC bus cable, which is 2 meters long. The tricky part is the next one, the next layout, which is landscaping in a single row. So here, as you can see, you will have to see that the junction boxes of those 2 PV modules are facing each other. In that case, the distance between the 2 microinverters will be around 3.5 meters. So you will have to use the AC bus cable with 4 meter drop, because the length of the panel is around 1.75 to 1.8 meters. So adding like 2 lengths of those panels, because both of them are in landscape mode, it will be like close to around 3.7 to 3.8 meters. So if you'll use an AC cable, which is 4 meter long, then this will probably solve this problem. And this is also an important aspect when it comes to the installation side of things, connecting microinverters to the AC bus. Most of the times installers, they are in a bit of a rush, and they are not connecting this thing properly, and they might have to go back. So the easiest way is just connect these two cables and hear the click sound. As soon as you hear the click sound, it means that it's connected. Try to connect it properly if you are not, until you are not hearing that click sound. So yeah, just tell your installers to check for this click sound. Okay, attach microinverter to the PV racking. So as you can see, DS3 has got like single attach point, while the previous version of inverters, the YC600, QS1, YC1000s, had dual attach points. Here, the note says like, do not mount the microinverter in a location that allows it exposure to direct sunlight. So as I said, just try to mount the inverter behind the panel rather than mounting it between the two panels. So that will just avoid this error. Plus, just allow a distance of around 1.5 centimeters for DS3 and 2 centimeters for QT2 above and below the inverter for good heat dissipation. So in this case, on a day like today, when the inverter will get like a bit more heated than usual, then it will just increase a bit of life of the inverter. Okay, so I'll hand over the presentation to Nigel now, unless Nigel, if you want to just put stress on some of the other points which has already been discussed. So Nigel will carry on with the commissioning on the EMA Manager app part. Thanks.
Thanks, Ravi. Nah, you've done a good job. So I think the installation part is the physical part anyway, has been explained pretty well. So what I'm going to be explaining is the commissioning of the system. And this is usually when, everything's installed and you're trying to activate and turn on the system. Now, there's actually two ways to commission the system, but what we definitely recommend, the easiest is the most recommended way, is by using something called an EMA Manager app. So this app is also known as an installer app. So if you do have the app, which I'll show you the diagram, it will literally say installer only. There's also another app just for the customer, the end user, and that's called the EMA app only. So just don't get confused with the two apps. So the app is free to download on ISO App Store and Google Play Store. So I'm pretty sure every installer would have a mobile phone. So I'll recommend they download the app and make sure it's the latest version, because to use this app, it literally takes maybe 5 minutes to commission the system afterwards. Then trying to do it the other way by using the IP address and all that kind of stuff, and that's the really old way which we used to do. So the EMA Manager app, it also allows you to log in as a installer profile to monitor your own clients as well. If you're on the go, you can do it, but I always recommend if you're going to be managing your customer's account, probably better if you just do it on a PC. It's the same login. So we'll go to the next slide. And so before you actually, this is my tip. When the installer go on site, before they even get up on the roof to start installing the panels and the microinverters, it's best practice to actually plug your ECU into a power source and plug it to your Ethernet cable if possible. And that's because the ECU, sometimes we give out ECUs or your batch of ECUs may not be the latest updated firmware batch. And so if you were to say you've installed your microinverters and now you've plugged in your ECU and try to use the EMA Manager app, it may not work straight away because the ECU is still updating its firmware once you plug in the power source. And that could take sometimes half an hour to an hour. So my tip is just try to plug this device in. Whether it's the ECU C or the ECU R, just plug it to your power point, plug it to the Ethernet, it will automatically update itself. And then by the time you get off the roof, you can start doing the commissioning process, which I'll explain in the next slide. Also, just to reiterate, make sure your EMA Manager is the latest version. Some people already have the app, but they have the old version, so that could create issues as well. So once you've downloaded the EMA Manager, this is like an iOS. I think it's the Apple Store, so it looks like this. So just download, it's free. Once you download this, then you click on the app. This is the front page. Now, just so what we're going to try to do is make sure that the installer press the local access button. And then basically, once they click on the local access button, they will get to this page and they'll ask you to connect to a device. Once you do that, it will then take you either it will take you to the Wi-Fi page, or it may take you out of the Wi-Fi page to the settings page. So what you want to do is you want to go to the Wi-Fi page and check the hotspots. And if you have an ECUR, it will look like something like this. If you have ECUC, it will still say ECU, so you won't really miss it. And then you will then connect to it. Now, if you go to the hotspot and the Wi-Fi list and you can't see the ECUC or the ECUR, that's because sometimes, or not sometimes, but the ECUs only broadcast their hotspot signal for 1 hour. And so what you want to do is you want to press the AP button on the side of the ECU to reactivate the hotspot. So then that hotspot or signal from the ECU will pop up on this list here. Just additional note, ECURs do require a password to access the device locally. Every single ECUR password is just 8 lots of 8s, just that. And then ECUC does not require a password. So once you put in a password or you don't put in a password, you connect, you would see this on the page. It will say connected and it says no internet, which is normal because what it's doing is the phone or the mobile phone is connecting to the ECU locally as a closed local system. And that's what you want to achieve. Now, once you've done that, you can press back or you can press home page and then you go back to the EMA Manager and it will take you to this screen here. So this is the home page of the ECU. Now, obviously, this page is showing that it's already connected to one inverter, but normally it will just say 0 and nothing here because you haven't paired anything. So once you get to this page, you really have 4 things to do, or really 3 things to do. So you want to then scan the microinverters into the ECU. You want to set the date and time, and you want to set the grid profile. Now, I strongly recommend the customer, whether it's the ECUR or the ECUC, you try to plug it to an Ethernet connection permanently. But if that's not possible, you can obviously connect it to a Wi-Fi, and we'll show you how to do that as well. So the first one we'll try to do, or we'll not try, but we'll teach you to do, is we'll show you how to scan microinverters into ECUs. So on the make sure, okay, so we're back a step. So once you're in the home page, you want to click on Workspace, which takes you to this menu. This workspace basically lets you do all 4 things, okay? So once you click on Workspace, it will look like this again. And for inserting the microinverters into ECU, you click on ID Management. And then you get to this screen, and then you click on Add. Now, once you click on Add, you have 2 options. You can either scan the microinverters on your phone and scan the IDs, or can manually insert the IDs on your phone. Now, I'm going to take one step back. Every single microinverter, DS3s, or whichever brand that we sell, there always will be 2 serial stickers on the microinverter. When the installers go on the roof to install the microinverters, they're supposed to peel off one of the stickers and stick it on, like, I don't know, on a piece of paper or piece of cardboard on the layout of their panel layout. So whether using knee maps or pylon, it doesn't matter. You generally want to print that, and then you want to peel the serials and stick it on those panels where you've installed them. Once you peel the stickers, the reason why I'm mentioning that is because when you're using the scan code input, it's easier. It's way quicker. So if you got like 10 inverters, you scan it, and then it will just be like, less than a minute, you can scan all of them in, or you can just manually input them. Whichever works is fine. Once you've scanned those IDs, usually the scanning tool is pretty accurate, like 99%, but just maybe double check sometimes. And then you press OK. Once you've scanned everything and you press OK, it will take you to this screen. It would have all the microinverter IDs. They all look gray. What you want to do now is make sure you click on this top left bubble. And then if you have clicked on it, it would make everything green. And then you click sync. Now, if you click sync, all the inverters on the right-hand side will say OK. And that means that you've synced the microinverters to the ECU locally. And that's it. That's it for the syncing of microinverters. It's just simple as that. So after you've done that, which took maybe 2 or 3 minutes, you then set the ECU date and time. Quite straightforward. On the workspace page, you go to ECU date settings. And then I didn't get a page for the next page, but it just basically is simple. It's just a page where you put in the time, or there's a button called sync phone time. So obviously if the installer is local, like if it's in Melbourne and you press sync and the customer's in Melbourne, it will obviously sync the Melbourne time, or if it's in New Zealand or wherever you are. Okay, so that's the quickest way. So once you press OK, this device will just sync. And then the next one, you then also want to do the grid profile. So there's a button, grid profile. And once you go to that page, which looks like this, you obviously choose your continent, your country, and then your grid profile. Now, we update our grid profiles pretty often. So if you have like new regulations and all that kind of stuff, it should pop up. Generally in Australia, you want to use this one. I think there are newer ones, and maybe there are ones for Queensland. It will pop up. Just choose whichever one you need for Australia, New Zealand, or New Caledonia, for example. Those are the default ones. Now I know that, for example, a lot of areas in Sydney, like in the Sydney patch or the Melbourne patch, sometimes these profiles are pretty narrow, and it causes your inverters to play up. So if that happens, we can still manually change the profile, so to make it a bit more tolerant for high AC grid voltage. Just say your street has 260 volts instead of 230. We can increase it for you sometimes. So, but as a default, just make sure you pick the correct grid profile. And once you've done, there will be a button that says it just says click update, and that's done. So basically, you've done all 3 things. That's pretty much all you need to do to commission it. But however, if your customer say, look, I don't want to put my ECU R next to my modem, or maybe that the customer has a shed where he's putting his panels, and the zigbee is like more than 100 meters the signal. So then you might want to get like a Wi-Fi repeater on the shed, and then you put the ECU at the shed. Then in that case, you probably would need to connect it by Wi-Fi. So again, it's pretty simple. If you want to connect your ECU-C, whether it's the ECU-C or R, doesn't matter. Same functionality. You click on the ECU network settings. You then click on WLAN. Make sure you swap it on, and just find your home network. Now, I recommend that if you are going to be using the Wi-Fi connection, at least want to have 3 bars. 2 is not good. Okay, 3. Because if you have 2 bars, it might drop to 1 bar and it disconnects. And then customers complain like, I can't see anything on my monitoring because it's patchy. So just make sure you have 3 bars. Otherwise, get a repeater or get a booster for the antenna. Obviously, then put the password in, save, and that's done. Yeah, like I said, if you can, just put Ethernet cable. You'll never go wrong with that. So that's my recommendation. So I think that is, yep. So we'll go next page. So that's the end of commissioning. So that's all the installer on site will have to do. Technically. So that's they can leave basically. Now, if they've done everything correctly, then on the home page again, he would see, just say that we go one by one, but just say that he has 10 inverters that's installed. It should say 10/10, and it will tell you the current power. It should have 2 green lights. That means the system's working locally, so the customer can access the data locally. However, obviously, the customer would not want to do that because they want to access the app on the phone and remotely monitor the system. So the next thing we need to do or the last step really, is to create a customer account on the EMA portal. And we'll go to that now. Like this one here. So just so you know, the EMA portal is not just something for you to create a customer account. It also allows not just AP systems like myself. It also gives the installers or retailers, whoever manages their customer's account, to do quite a few things as well. So at the end of the next topic, I'm going to show you some tips and how to determine like things like disconnected cables, bad panel, poor communication, breaker trips. So instead of like in the customer calling you say, oh, something's wrong with my system, I can show you by looking at the EMA portal on your installer access, potentially what is wrong before you go out. So it saves you a lot of time. Like I said, it's truck roll prevention tool, and you have a quicker turnaround resolution time as well. So, but before we do that, we're going to show you how to create a customer account. I'm going to show you this as a live demo because if I were to snapshot every single thing, it will just take forever. So what we're going to do now is I'm going to log in to my account. And so my screen may look similar to yours, but to your installer profile, it's the same. I might have more features, but you should be able to follow through. So on the main screen, you want to go to registration. And then you want to add a customer. So here you obviously create your customer's account. Now every installer or retailer have their own kind of way of creating the username. People might want to use the street name and street number and street name, or just directly put the customer's name. I think it's better if you just use the street number and then Smith Street. I think that's pretty easy. The password doesn't really matter what you put in because end of the day, once you create the profile or the account, it will send an email to the customer to create a new password anyway. So normally I just put in 1, 2, 3, 4, 5, ABC. Same thing here, 1, 2, 3, 4, ABC. Customer name, I'll just put myself Nigel. You don't really need to put a last name, but I'll just put it in anyway. This is important. You need to put in the email address of your customer, not your own work email. Because like I said, once this account is created, it does send an email to the customer, the end user, and then to prompt them to create a password and log in. So I'll just, this is a test account, so it won't matter. And the customer's phone number if you want to put one in, but I'll just leave it blank. You can put allow visitor to access this system. Generally speaking, I don't think you need to, because as an installer, you will access the customer's account anyway. And as a customer, they just log in with their own details, so you don't really need this. Here, you obviously choose your country. We'll put Australia. I'm not sure exactly, but if you're the installer, you might not able to choose this because you will just default to your company. But if you do have this, then you obviously pick your company name or your user profile. Now, if anyone's watching this video doesn't have an installer profile, I will show you the link where you can register for one. So then I can create one for you. And so when you create a custom account, you can search your own name. For the purpose of this demonstration, I will just use the default one. There we go. Then you put Australia, and we'll just, let's put Tamworth. I know. Doesn't matter. It's always good to also put the address entirely, even though it's optional, because sometimes you may have install done like 4 years ago, like 4 years later, you want to know, and you lost record of the customer. This portal here has all the things you need, so you can just put in the customer's address, like 4 or 3 Smith Street in Tamworth, and then whatever the postcode is, like 25000, I don't know, something like that. Here, system size, obviously you put in the panel size of the total system. So 6.63 is pretty common in Australia. Module type is the name, so just Trina panels. And then the wattage of the panels are 390 maybe. Grid type, single phase or 3-phase. So we'll just use single phase. If you want to put any prompts to yourself when you access this customer's account, you can put remarks. It's up to you. I'll put nothing. Then you press submit. Don't save. So here you put in, you add in the ECU of your customer. So you press add. So you obviously want to make sure you jot down the customer's ECU number. For the purpose of this, we'll just make one up. ECU name. Some properties might have multiple ECUs if they have like a massive big commercial project, which I'll show you a demo in a moment. If you're looking at a normal house, just leave it blank because it's only going to have one ECU. So just leave it blank. It's not really required. So you press OK. And once you have the ECU, you press next. Off. So this is where you add the inverters into this account. So you go to add. Now, back when you went the previous slides, we talked about commissioning the system. Now, if the installer, because I believe if you're like the installer, like installer that does everything, then you would know. But if you're like the back house support, then you want to make sure your installer has done everything correctly. Because if they have, and they did scan all the inverter IDs on the ECU locally, all you need to do is click insert UID to temporary list. Now, because obviously this is a dummy account, it's not going to pop up. But if they have scanned 10 inverters, like I said, on the commissioning part of things, it will just pop all 10 inverters, and all you need to do is just click submit. In this case, you can also manually add the UIDs, which I'll show you now. Let's just say the installer just forgot, which is a big no-no. You can just choose your inverter, DS3S. Make sure you choose 1 and 2. Now, sometimes installers might only have to use one channel of the inverter, like because maybe you want to put 3 panels on the north roof, so you're only really having to use one channel. So just make sure you click 1 or whichever channel that's in use, because if you have both channels, you're going to create a bit of a mess on your monitoring because you have a channel that's not plugged in, but it's been registered. So for this one, we'd say you're using 2 channels, and we're adding a DS3S. Let's make a random digit, and then we'll add 2. Just make it a little bit nicer. So once you've done that, then you click on this. Done. Make sure you've ticked everything, and then you click submit. Now, this is a step a lot of the installers keep forgetting. Once you have it all here, you also have to click on this, select everything, and then you link it. A lot of times I get customers calling me saying that I've done everything correctly. I've added the inverters are showing NC or blank on my monitoring. It's because they forgot to link the inverters, like establish the zigbee connection. So just make sure you click on all of them and click link, and click and just leave us all and just click send. That's it. And then you press next. So here we're making a view of your panel layout or your channel layout. So you click on add. So there's 2 ways of doing it. You can do the lazy way or you can do the more advanced way. We're going to show you the easy way today. So the name of the view we'll just put roof. It doesn't really matter. Always put 1 and 1. And I'll show you why in a moment. Just click create. And this is the part where you model your map. So each of those here is 1 channel. So those 2 here is 1 inverter, but channel 1, channel 2. So you can just drag and drop. Let's just say I have 2 panels facing north on a northern roof and 2 panels facing west. So that's one inverter facing north, and then that's one inverter facing west. Now you can make this look a bit nicer. Let's just say it's either way. Let's just say those two panels here are actually landscape. They're actually not portrait. So you can actually right click them and have them as landscape. Or like I said, because you're lazy, you want to use one page, because normally you need to put one page for north and one page for west. By putting them together, you can just prompt yourself by just changing that to this. So it looks like this is just the whole view of the house. So there's two panels facing north, two panels facing west, and then you save. And that's it. And then you click next. So this is system pictures and drawing pictures. Now, I also strongly recommend if you have a photo of your knee maps or pylon design for the customer, or if the installer do take photos of the panels of the roof, upload them here. It saves you a lot of trouble because after 5, 6, 10 years later, having those visual aids helps you to deal with warranties much easier. So if you can upload the schematics, the single line diagrams, even the PTC approvals, everything you can upload, just upload them here. Just click on it. You can just upload all the files you want. Up to 10 megabytes per file, I think. So that's pretty big. And so yeah, so it just makes it easier for you to come back to this job if there's anything wrong. Then you can bring all the documents from this page or in the customer's profile. So once you've done that, you click on complete registration and make sure that's ticked, because once you click on this button, it will send the end user or the customer a email saying that your account has been created, and to create a new password and log in. And then they should be able to log in to see everything. I'm not going to click on this one because this is a dummy account. By also clicking on this, you will also have another job or another installation on your installer view. Now, in case you don't know what it looks like, I'm gonna show you something quite interesting. So let's just say that you want to know what the customers are looking at. On this page, which is the login page, there's actually a demo button here. Now, in case you want to see, there's a demo DS3 installation we've done, I think it's in China. And this is what it looks like for a customer if they log in on the computer, okay? So on the computer, this is what they see. This is live data for today. Be mindful they are 3 hours behind, so it says 12 o'clock. Weekly and all that kind of stuff. They can click on module. They can see individual panels, how much power they're producing. Be mindful that 47 is 47 watts of the inverter capacity, not the panel capacity, which is down here. DS3 is about 625 divided by 2, so about 300 something maximum watts anyway. So you can drag the slider down here, see how it's performing, make sure there's no drops and some random stuff that's that's causing issues. You can go on 30 days. If the customer's complaining that, oh, like last week my panels were not working, then instead of like checking every single day, you click on the 30 days and you drag and see which days it went zero, like for multiple days. Now you can also just change the date further back, and then you can keep looking at it. There's also more stuff you can do. You can look at report, like how many kilowatts of power they've produced per month for last year, and compare them. Now be mindful, this customer is using an ECUR. So this is what they'll see on the ECUR. Now for a customer that's using ECUC, they would see more things. And so you want to see what that looks like. I believe this one is a ECUC. So you'll see more things on this one. So it will look different like this. So if you have a ECUC, if you got the CTs installed properly, then you'll see how many you produced, how many you imported, how much you consumed, how much you exported. Now this one, we actually taken a photo of it, so that's cool. You can see all the panels here. I believe this is a closed circuit, so it means that there's no export. It's just, that's why it says 0 export. I think this is a test site. And then you can see here, produced, import, you can see everything basically, like what's happening. So if the customer's having an ECUC, that's what it looks like, and you see real life data as well. I think that kind of shows the account creation. So we'll go back to the PowerPoint. Any questions, by the way, before I move on? All good? Yep.
Nigel, can I ask a question?
Sure, go for it.
Yeah, hello everybody. Sorry, I came in late. I have a question about you showed two different views. Is it something we can custom, or is it something that is established at any time we cannot change the view that we have on the monitoring?
So you can't change the view because, like I said before, those two views, it depends on which ECU you have installed for the customer.
Okay.
So the first one was just a simple ECUR, so it only shows you output of data from the microinverters. The second example I showed was the ECUC, which is the one that comes with export limiting and consumption metering. And so that's why the second one has more data, because you can see how much power you are importing from the grid, how much you're selling to the grid, and how much you're producing. So you need to make sure you pick the right.
Yeah, but
product.
we can't anyway customize it, right?
No, you can't really customize the UI interface for now. Yeah.
All right. Okay.
There may be some changes next year where we're changing the program, but everything you need is pretty much there. But the views are set. Yeah, fortunately. Yeah.
All right. Thanks.
That's okay.
Yeah. Yeah.
So we're gonna move into troubleshooting with EMA Portal. I think that's probably gonna be the most useful thing for everyone, because after support is important. So just a couple of easy things I can show you first. I think 50% of the times the customers have some kind of issue. It's not really the inverter. It's actually just the communication and just not able to see their solar system on the app. Now, unlike our competitors, the relays of the inverters are built in the inverter. The ECU does not have a relay. So what I'm trying to say is that if you have a system and the ECU just does not work, you cannot see the inverters, but the inverters will still work on the roof. So you can at least give them a bit of peace of mind to the customers that, yes, your ECU is not showing anything, but chances are the inverters are still working on the roof because they have their own built-in relays and they're using DC power from the panels. It's just that maybe most likely the internet is disconnected from the ECU. That's why it's not uploading data to the cloud. So if a customer calls and say, look, I can't see anything on my app, the first thing you want to do is ask them, is the two green lights on this device, or the ECUR anyway? So the first light is the power light. That has to be on. If that's not on, that means this device is gone, it's dead, or the power adapter is dead. So usually they will say, yep, the first light is on, and then the second light, which is the internet light, I guess you call it, if that's off and the power light is on, that means that the device has lost internet connection. Hence, it's not transmitting data to the EMA portal. And then obviously then if you have an app, you can't see your inverters or your data. So then what you want to do is you obviously want to make sure the customer, like, ask them two questions. Is your ECU connected to Ethernet, or is it connected to Wi-Fi? Generally speaking, if it's connected to Ethernet, you shouldn't have this issue. It's generally customers who have Wi-Fi that may have this issue, and then you want to ask them like, hey, can you, because the ECURs are like portable, you can ask them, can you put this a bit closer to your modem? and then plug it back in again. It generally resolves the issue. But if not, then obviously you have to do a bit more troubleshooting. Now in Australia, and most likely because we ship our stuff from Sydney's warehouse, so in New Zealand and New Caledonia as well, not that important to you guys, but on the back of the ECU, this middle slot where my mouse cursor is, there's something called a crystal port. It's a plastic plug. In Australia, if you remove that plug and there's a firmware update, which happens, I don't know, every few months automatically, your system will shut down and will not turn back on. So you also want to make sure customer just didn't randomly pull this off or take it out. Because if they did and the inverter's offline, that's probably the case. So there's a crystal port here. Do not remove it. In New Zealand, in New Caledonia, doesn't really matter. In my recommendation, just leave it there. Just don't remove it anyway. But that's this is not just in the ECI. It also happens on the ECUC. There's also crystal port on the ECUC. Just make sure that you don't remove it. So again, ECUC, there's also 3 lights. Oh, there's 2 lights and plus a 3rd light. Again, ask them if the power light's on or the comms light's on. Again, if the comms light is off, try to check the internet. If it's still not working, plug it to Ethernet. And if it's still not working, then you contact me. So that's pretty much one of the biggest things I guess customers would will have issues with. So that's just going to cover that one. Now I'm going to just show you also now more live demos, because it will take forever if I will try to do screenshots of every single possible scenarios, but I'll show you some common ones. So I'm going to log in to my account again, and I'll show you some live cases that I've done. That's not right. Just use another one. Okay. I've got this case here. Now, normally you look at the light, you might have a list of, I'll show you that in a moment, but you see it's yellow. Yellow means something's wrong. Okay, that's why I'm bringing this up. Now, what you do first is you want to go straight to module and see why the customer's complaining. Be careful, because like I said, I showed the lazy way of creating the map, but the proper way of creating the map is, you see it, this says east roof. You have to click on it. There's actually a north roof as well. And so the issue here, obviously, you can see is, why is that panel showing 0? And the customers complain, oh, my panel's not working. Now, as an installer, I don't think customers can do this, but installers and myself with the admin level, you can actually go and click on this. We call this a channel, okay? And then you see how there's something called detail. You can see the stats. Now, you want to click on this and click on all. It will show both channels. Now, what you want to do is the easiest is unselect everything because there's too much clutter. And you want to compare the VOC of both channels. A normal VOC for a panel is about 30-ish watts of volts, So channel 1 is obviously working. If you look at power, yep, it's producing power. But channel 2, it's not producing power. Like you see that line there. Now for DS3, it's really easy to tell. If your DC voltage is hitting around 8-ish, it means 2 things. Either this channel is not in use, you've accidentally added the channel, and there shouldn't be a second channel here, or the channel is loose. So it means that the installer didn't snap the MC4 connectors tightly. And so someone has to go back out and replug the panels, or they have to check the paperwork whether they actually did install 2 panels on this inverter. So this is one really, really common thing you can troubleshoot. So so see how it says about 9, 8. That's a really telltale sign of a channel not plugged in or not in use. You can also double check everything by looking at the grid voltage. It's good. See, it's hitting around 240. It's a bit high, but that's normal. So it's clearly that it's a channel that's not plugged in. I'll show you another example. Again, it says yellow because something's wrong. So again, you go straight to module. Now I'm going to go yesterday. Actually, I can just even show you. You can clearly tell something's wrong. So those are the northern panels, and those are the western panels. Now, obviously, the northern panels are not working, but the western panels are. Now, you can, I mean, as a installer, or even for myself, you can kind of guess that those panels are in one trunk, and those panels in the second trunk. There's two, like bus cables, I guess you call it, because there's 1, 2, 3, or 5 inverters, maybe. I think there's. Now, then what you want to do first again is two things. Before you even get into looking at the details, a good tool is you go to alarm information and you look at protection data. This is where all the alarms are. Now I can explain what each of them means, but then again, it will just take too much time. But simply, you can just hover over one of them and it says the grid voltage is lower than the inverter AC output voltage limits. So you go, okay, what does that mean? So I can tell straight away what it is, but it's something wrong with the AC voltage. Okay, so what you want to do is you then go back to those panels, you click on detail, click on it, or unselect everything, and you just want to select the AC voltage. Something's clearly wrong because this should be around 230. So most likely, the northern panels have an AC disconnection. So it means that the bus cable, before it hits the junction box, most likely, there's a loose connection somewhere. And because if the AC voltage is not to a certain limit, like the alarm said, the inverter will not produce power. It will not start up because it's a safety mechanism. So unless this AC voltage hits 230 or 220, whatever the limit is, those panels will not turn on or not produce power. So for this one, you can tell the installer that, hey, look, I think that those panels or the trunk line is disconnected. And you can kind of even guess that because those panels are working, it means that the issue is somewhere between the junction box to the first microinverter on the roof, on the northern panels. Because if something were wrong between the junction box to the inverter, to the switchboard, then these panels will not even switch on anyway. Because if you look at the data on that one, the western panels, the AC voltage is normal. It's normal enough anyway. So it's 240, 250, whatever. So this is another example if you want to know whether the it could also mean that if this installation were 2 breakers, it could also mean that the breaker's been tripped. So it could be both. It could be an AC disconnection or it could be the breaker has tripped. But I'm more probably leaning to the AC disconnection. Okay. Another way to know whether the inverter are working or not, there's also another really good tool. You go to diagnose under here. You can see something called report count. Now, if those northern panels show 0, it means the inverters are faulty in the first place. What it's saying here is that the northern panels or the northern inverters are working because it's every 5 minutes it's giving you a report count saying updating what's happening. Okay. So clearly it's nothing to do with the the inverter, and also you can tell it's nothing to do with the panels as well, because if I look at the VOC, of both channels. The panels are producing those power. It's normal. So like you see, if something were wrong with the panels, that would show like 10, 20, depending how many diodes they have. So it might show 10 volts. So that's a good tool. Okay. Now just be mindful. I'm going to show you another thing, and I think this is going to be the last one as well. A couple of things you also want to check is that you want to make sure you go to ECU setting, that you've make sure you linked everything, and make sure a link is all here. Sometimes the panel shows 0 because you forgot to link them. Like I said, remember how I said when you create the account, customers the installers may sometimes forgot to click the link button. So if they haven't linked it, just simply click on those, and just press send, and that links the inverters. But in this case, it's already linked. You also want to check when's the last time the ECU has communicated to the server. It's 5 o'clock here. So it means that the ECU is fine. Because what I'm going to show you now is also another really common issue. And we'll just look for Australia only. So green is all good, and then you might sometimes get a customer that has a black icon. Okay, so what does that black icon mean? So you click on that. A black icon means that the ECU has never been connected to the internet. So if you want to make sure, you click on diagnose. Well, it has been connected, but you can tell here that there's something wrong with this customer. Like the internet is still connected, but the inverter is not producing communication. Okay, for this one, the panel is showing 0. So the steps you normally want to do is make sure 2 things. First thing you want to check is the panels linked? Yep, it's linked. And the second thing is you want to check the version. Okay, now this is something that goes with experience, but for ECU, this is 215. That's ECU C. Any version less than 1.2, the DS3s will not link. So the reason why this job or this system is not connecting to the inverters is because the firmware is too old. Now there's 2 ways you can update the firmware. One is you can just tell the customer to press the red reset button on the ECU, and it will reboot. Or if it still doesn't work, just shoot me an email. I can get someone to force update this ECU. Okay. So if you get a customer that just shows black, it means that the inverters is either the firmware is not updated or it's not connected to the internet yet. And these are usually quite common for newly installed jobs. So this job was installed on 12th of today, I think. So that's probably why. Most likely the ECU is not updated yet. I'll find another one, last one, and then we're done for that one. So we'll just go to another black one. So this one's black, no reported, and then you go to this one. See here, this one, nothing here. It means this ECU has never been connected to the internet at all, not even once. So in this particular case, if customers like saying, hey, why is my system not working, not showing anything? It's because your unit's not connected to the server. Now, this is something that it's not really the customer's fault because, like I said, the ECU should be connected by the installer on site on the day anyway. So this shouldn't have happened in the first place if the installer have done the correct procedure by commissioning the system, plug it to Ethernet, or connecting it to Wi-Fi. Because if they've done everything correctly, this should not be blank. And also for me, as the tech support, if that's not showing anything or there's no Ethernet connection, I can't help you because I can't remotely send signals or commands to the inverter if there's no connection. Okay, so I think that's the most common cases for DS3s. Generally speaking, they're quite reliable compared to the previous models. So I think we're done for that one. Now, if you want to, you can check all of our. Oh, first of all, if you haven't already, you can register your installer profile on this link. And if you want all the manuals, the brochures and stuff, that's all here. It's really elaborate, so you can easily get all information from here. And yeah, any questions from anyone?
Yeah, if I can ask a question.
Yeah, go for it.
It happens sometimes we have a unit which is not responding. So let's say, for example, a YC600 or even a DS3L unit is the both channels are off. So what we do is we go there and we switch it with a new one and it comes back on. The question is, can it happen sometimes that it's only a matter of it shut down and maybe we could turn it on or we could do something to get it back on the system? Can we do something before we go and switch it?
Now, the ECUs are supposed to be compatible, the ECURs anyway, ECURs and ECUC should be compatible with the YC600s, which is our legacy models, and the DS3S. I think most of the times when that happens, like showing that is it the YC600s that's showing blank or both the DS3 as well?
No, sometimes we have well, we had more QS1. It happens more often, and we had some YC600, but more often was QS1.
Oh, okay. So the QS1s are remotely shutting down. Is that correct?
Well, it was off. So 4 channels were off. So we couldn't get more into it. So we came on the roof and we switched the unit and we replaced it with a new one. So, but we didn't investigate further. And I wanted to know if it's possible with this tool to restart it or trying to restart it. Maybe it shut down or something. I don't know.
I think what you should basically do, as I mentioned before, if you have any inverters that's showing, that's not showing up or showing really bizarre result, I'm going to bring up the one of the pages, is you always want to go to alarm information and look at the protection data, because it could be anything. So it could be the voltage, it could be the V-bus, it could be a short circuit, anything. Now, however, I know that when you try to use cross mix of panels, inverters on the same ECU, there has been some issues because you need to make sure that the ECU is updated to the latest firmware when you try to mix 2 inverters together, because some firmwares are more designed for YC600s and some are more designed for QS1s or DS3s, but we've made sure that the newest firmwares we have will be compatible for everything in the same unit, basically. Okay.
Yeah.
Now, if the QS1 that you replaced, was it just in the whole setup, was there only one QS2 QS1 inverter, or was it only just there's multiple QS1s on that setup that you had issues with?
It was only one in the middle of several QS1.
Oh, okay. It could just unfortunately be a faulty issue, or it could just mean that that the voltage of that particular inverter was hitting some limits. And if that's the case, then you had to send me an email and increase the tolerance so they can handle the higher V-bus or AC voltage and so forth.
All right. That's something we cannot do on our own, right?
We can give you access to change parameters, but we prefer not to, because it can create more trouble than not, because it comes with experience what you can change and what you can't change. Yeah, so I'm still in discussion with my boss, like whether we want to give AUNZ all the access to change like in every single parameter, because it can destroy your warranty, because you might accidentally put a figure that's completely out of whack and then short circuit the inverter. Now, if you go to alarms, just give a good tip. if you go to alarm, if you ever see a inverter showing only CP protect, and you see
Okay.
and it's just showing CP protect all the way through, that inverter is gone. It means it's been short circuited. I've seen a DS3 being short circuited straight away in 2 days because one of the installer who I gave access to the parameters, he's increased the inverter max power from 625 for DS3S to 800.
All right.
And then it blew, it just destroyed it. So because remember how I said when you put in the max power, 625 watt inverter per channel is only 300.
All right.
The installer puts 625 on one channel, which is double what it's supposed to be. So like things like that. So that's why we don't give you access until we have some kind of foolproof way of fixing it. Yeah.
Yeah.
Yeah, so I think there's not much else I can cover. I think I covered pretty much most of the case studies. But again, like I said, if there's any unusual cases, send them through. I might add them into the video or add them into a proper template. I guess is there anything else you want to say, Ravi? I think we went over time, but sorry.
No, that's okay. I think everyone from Australia, it's already overpassed, so they have logged off, but they told me that they are definitely gonna access the recording, so shouldn't be an issue. But thanks a lot, Andy, Thierry, and Nigel from SolarCo, and to Nigel from AP Systems as well. Thanks a lot for the deep insight that you have provided on the installation and on the EMA troubleshooting. I'm sure Andy and Thierry would have got a bit of an idea on how to do a bit of troubleshooting from their end as well. And yeah, feel free to shoot any questions if you guys have. If it's not like popping up in a split second, feel free to send it to us via email as well, and we'll be able to answer that.
Yeah, good on you. Thanks to both of you guys. It was really, really useful. So appreciate your time.
Thanks a lot, Andy. Thanks Thierry and Nigel. Thanks a lot.
Thanks, guys.
Also, thank you very much for your time. Thanks.
Thank you.
Cheers.